After studying this module, you shall be able to know what is forensic facial reconstruction, importance and accuracy of forensic facial reconstruction, various assessment methods and 3D models, and the importance of forensic facial reconstruction in post-mortem depiction. To introduce you the topic of this forensic facial reconstruction, at the turn of the last century, a pioneering researcher in the forensic facial identification predicted that anthropologists in the new millennium would spend considerably more time trying to understand the human face, how expressions are made and how the face changes, by Scone in 2001. Commenting on the 60-year contribution anthropology had made to the forensic research and the medico-legal processes, Scone anticipated that diet, physical environment, disease, genetics and aging were prime sources for information on transformative human facial morphology. In the first decades of the 21st century, other practitioners evoked this shared perception of forensic anthropology as increasingly multidisciplinary, as advocated by Catania in 2007, anticipating further ingress of improvements already achieved in computer science and medical imaging technologies, which would continue to have significant repercussions in the field, as said by De Graaf and Williams in 2005. Research on forensic facial reconstruction henceforth will be called as FFR. These techniques incorporate new information on estimating the facial appearance in manual and computerized applications. New soft tissue depth data sets obtained with computed tomographic scanning, that is CT scanning, the MRI, that is the magnetic resonance imaging, and ultrasound provide a wider range of information for those reconstructions. Continued development of computer mediated image production and manipulation predominate in FFR. At the same time, these technical expansions contribute to new studies on postmortem depiction and influence the execution of facial superimposition. Debate on the nature and position of FFR in science as opposed to art recur unabated. The aim of FFR is to recreate the facial appearance of a deceased and unidentified individual so that it is sufficient in resemblance to facilitate recognition. Facial reconstruction is often a last resort when other means of identification have failed and must be corroborated by radiographic, dental or DNA evidence to stand as a positive identification. Two basic techniques are utilized in this, the two-dimensional 2D and three-dimensional 3D reconstruction. Each technique is further divided into manual and computer generated methods. Now let us see the 3D manual methods, which include the anatomical or Russian, anthropometrical or American, and combination of both, that is Manchester methods. The differences in nomenclature have arisen from variation in disciplinary approaches and diverse regional origins. The anatomical method relies on the primary influence of muscles as informed by skull morphology in constructing facial form and features. The anthropometrical method, in contrast, emphasizes average facial tissue depth in facial depiction rather than the anatomical relation between skull and facial structure. The combination method is a fusion of the two in which average soft tissue contours, although important, serve as confirmation of structural details provided by muscle and bone morphology. Now let us see what is forensic facial reconstruction or FFR. Other than research relating to the relationship between the hard and soft tissues of the face and accuracy studies, 3D manual FFR publications have been mainly limited to case studies, reviews and some focal text. Two reviews, one by Vanagis in 2000 and other is by Verge in 2009, summarize the history and current practice of facial reconstruction in forensic identification. Both describe the origins, aims, advantages, limitations and essential methods. Both reviews referenced research documenting the critical relationship between the uniqueness of skull structures and the individuality of the human faces, thus directing students of FFR to familiarize themselves with foundational material underwriting the theory of facial reconstruction. In addition, Verge describes progress in the field, including Neolithic skull overmodeling, death mask techniques, the anatomica plastica movement of the 18th century Europe, a number of early forensic UK cases, and the powerful computing systems that contribute to current developments. Many publications have described archaeological facial reconstruction, including the depiction of Egyptian mummies, bog bodies, a 19th century Hungarian priest, a Danish 17th century nobleman, a Korean medieval child mummy, and an Italian Renaissance nobleman. Historical depictions of facial disease and trauma include the South American case of Leontiasis osseosa, a healed wound from the Battle of Teuton, and meningioma hyperostosis. Some researchers have evaluated manual and computer-based skull resembling and missing fragment remodeling, for which the effects of misalignment and errors in remodeling were assessed in relation to any resulting facial reconstruction. A pilot study using manual reassembly and remodeling as applied to a forensic case suggested good levels of reliability. Later studies of computer-based reassembly and remodeling confirmed this conclusion, with the exception of the mandible, for which the large errors in remodeling will have a negative effect on any reconstruction accuracy. Now let us see the importance of FFR. From the time facial reconstruction was scientifically introduced to the world in the late 19th century by anatomist Wilhelm His, there has been a great deal of research into the reliability and accuracy of the techniques. On one hand, scientists argue that the techniques are too subjective and rely significantly on individual artistic skill, resulting in reconstructions that are inaccurate. On the other hand, some researchers insist that FFR demonstrates good levels of likeness sufficient to be employed in forensic identification and justified if there are no other tools available to identify human remains. Now let us see the accuracy of forensic facial reconstruction. The Wilkinson and Whitaker in 2002 reported optimistic results on the reliability of facial reconstruction. They employed 5 forensic cases from the West serial murder investigation in Gloucester, United Kingdom. The 3D facial reconstructions using the combination manual method were produced from 5 juvenile female skulls and then compared to a face pool by 50 assessors. The volunteers were asked to select a face from the face pool that most resembled each reconstruction. The mean hit rate was 44%, where the rate by chance was 10%, demonstrating that facial reconstruction can produce a good resemblance to an individual. In contrast, Stephen and Henberg investigated the accuracy and reliability of facial reconstruction of 16 reconstructed faces employing 4 skulls and 4 different 2D and 3D facial reconstruction methods. The facial reconstructions were then assessed by 37 volunteers with facial photographs in a face pool. Only one facial reconstruction showed true positive identification at above chance rate, and 403 incorrect identifications were made in 592 identification scenarios. The researchers maintained that facial approximation or the reconstruction should be considered highly inaccurate and unreliable as a forensic identification technique. Further accuracy studies on the computer generated facial reconstructions have been performed. Wilkinson et al. Produced facial reconstructions from 2 CT scanned skulls with a computer generated 3D modeling system. 2 reconstructed faces, a white male and female, were tested for accuracy employing face pool comparison methods. Assessors were asked to match the facial reconstruction to the face from a face pool of 5 CT scanned faces, including the target face, that best resembled the target face. Results demonstrated that combined hit rates for both facial reconstructions were 50% above the level recorded by chance, that is 20%. Researchers subsequently completed a morphometric comparison using 3D surface software that is the rapid form, to assess the quantitative accuracy of facial reconstructions. Results showed that 67% of the facial reconstruction surfaces had less than 2 mm error compared to the scanned target face, suggesting high validity for computerized facial reconstruction. Reviewing the studies on the accuracy of FFRs, it appears that there are disagreements between researchers over the levels of accuracy and their reliability. Claes et al. And Wilkinson pointed out that facial reconstruction is not a method of identification. The final goal is not complete accuracy in reconstruction, but rather success in recognition. In assessing the limitations involved in assessing the accuracy of facial reconstructions, we are reminded that most success facial reconstructions are recognized or identified by those familiar with the person in question, whereas current empirical accuracy tests are based on unfamiliar face recognition due to practical and ethical difficulties. It is established that people are much better at recognizing familiar faces than unfamiliar faces. It is therefore suggested that the reliability of FFRs should be considered in light of the problems encountered in measuring success with accuracy tests. Nevertheless, recent research demonstrated an acceptable accuracy level for identification in both manual and computerized methods. Forensic cases have proved that the technique of facial reconstruction can be used to assist in the identification of individuals from unknown skulls, particularly when other forensic tools are unavailable. Now let us see the assessment methods for accuracy evaluation. There are a number of methods in use to evaluate the accuracy of FFR, and they may be divided into qualitative and quantitative assessments. Face pool and one-to-one matching comparisons are representative of the qualitative approach, in which participants are asked to identify a target individual from a range of faces in a pool or a single photograph of a face. Quantitative methods utilize numerical grading systems or specific computer software to measure the accuracy of facial reconstruction. The resemblance rating methods directly compares the reconstructed face to the corresponding target face. Assessors are asked to determine the degree of resemblance. The superimposition method overlays a facial reconstruction and a photograph of a target face with computer software, comparing facial morphology and proportions. Wilkinson et al. Employed a surface comparison method in FFR reliability research to assess the accuracy between facial reconstructions and CT or laser scanned target heads. In this technique, the reconstructed face was overlaid and the scanned or the target face and computer software compared 3D morphology to identify differences in surface contours between the two models. Claes et al. Have applied the 3D surface comparison method to evaluate the accuracy of computer generated facial reconstructions. The suitability of these methods for evaluating the accuracy of facial reconstruction is hotly debated. Stephen and Arthur in 2006 and Stephen and Ciccolini in 2008 maintained that a resemblance rating assessment is an insensitive method as resemblance scores are not particularly discriminatory. They performed two experiments to establish the applicability of two accuracy tests, the resemblance rating and the face pool comparison. In the first experiment, both accuracy methods were engaged for the same facial reconstruction. Results showed a poor true positive recognition accuracy rate of 21% for the face pool comparison in relation to a resemblance rating which is scored at 3 of 5 on a 5-point scale test. The second experiment, utilizing a resemblance rating method using 3 distractor faces from the same face array used in the first experiment, revealed that there was no statistically significant difference in the resemblance scores between each side-by-side comparison of distractor faces to the target face and the facial reconstruction to the target face. The authors insisted that resemblance ratings generated from a 5-point scale yield information of little value in regard to accuracy tests of FFRs, and that the current scale for resemblance rating needs to be replaced with one that is more discriminating. They suggested that the face full assessment method is a more appropriate tool for investigating facial reconstruction accuracy. On the other hand, Wilkinson and Whitaker in 2002 stated that the usefulness of a resemblance rating assessment must not be underestimated, and that a best assessment can be produced using both face pool and resemblance rating systems. As mentioned by Wilkinson, the extent to which facial reconstructions are directly responsible for the recognition and therefore identification is somewhat obscured. Perhaps the issue of which methods are most useful in assessing the accuracy of FFRs should be considered based on the perceptual processing of the human faces in cognitive psychology and different levels of artistic interpretation in practitioners. Now, importance in post-mortem depiction. The dearth of literature, theoretical or practical, on post-mortem facial depiction in forensic science is a puzzle. Techniques for reconstituting the physiognomy of the individuals when decomposition or environmental exposure has rendered faces unrecognizable after death remains an area of research largely unexamined. Decomposition is the destruction of tissues which is enacted by internal or the chemical autolysis or external factors, that is insects, carnivores, environmental, and is known collectively as the taphonomic processes. This post-mortem facial depiction is most frequently employed by forensic artists who utilize artistic ability, their knowledge of hard and soft tissue facial anatomy, and an understanding of the process of the body decomposition and taphonomic effects. A hand-drawn sketch or a computer-assisted resemblance of the individual face is produced in the hope that a public presentation results in recognition. When artifacts in association with the body are available, for example clothing, jewelry, evidence of hair type or style, or notable features of the head or face that may still be partially discernible, the artist is able to incorporate such information into the depiction. The forensic artist may work from photographs of grossly blotted, discolored and distorted faces, often with missing facial features. If crime scene image collection is inadequate, further photographs should be taken at the mortuary or following exhumation. The post-mortem depiction is utilized for deaths that are natural, suicidal or homicidal. In homicide deaths, blunt or short trauma and gunshot wounds to the face are frequent. Extensive damage to the face also occurs as a result of accidents involving traffic, drowning and fire, etc. A number of reliable descriptions of changes brought by decomposition, including the effects of variant environments, have been documented over the last 3 decades. They inform and guide facial image depiction as the forensic artist attempts the closest approximation of an in vivo appearance of the deceased as possible. Knowledge about a relatively rare product of body decay, that is adipose hair, is limited. First identified in 1658 and subsequently studies from the latter part of the 18th century, it was the focus of a study at the Anthropological Research Facility in Knoxville, Tennessee, USA. The relevance to post-mortem facial prediction is that facial features are preserved with little alteration to appearance, a condition favorable to reconstituting a desirable, publishable, sketched or computer-assisted facial depiction. Photographs of the deceased may, with the addition of skills in image manipulation and alteration, utilizing photo editing tools in software programs like Adobe Photoshop, allows the forensic artist to create a facial appearance acceptable for publication. The removal of mortuary or crime scene backgrounds from photographs, the editing of the wounds, blood and other substances from the face in combination with the reduction of blotting and discoloration, which are then replaced with the neutral tones, normalized contours, open eyes and relaxed facial expression, can transform the most graphically damaged visage to one that may spark recognition. Databases of facial features amassed and classified by age, sex and ethnicity can be pasted and blended as layers when insufficient clarity of detail in the damaged face promotes extrapolation of normalized appearance. It must be said, however, that the more distorted the post-mortem image, the greater the need for experience and expertise with regard to decomposition, and the greater the demand for estimation and interpretation. Data comparing differences in the decomposition patterns that reflects sex, ethnicity, age, variant craniofacial shapes and facial features are necessary. This reality is strikingly apparent when one considers the range in origins and ages of victims in mass disasters like the Bali bombing in 2002, tsunami in 2004 and Hurricane Katrina in 2005. The psychological barriers encountered by friends and family who suffer through identifying loved ones in the aftermath of disasters are compounded by the complications that decomposition in hot climate imposes, as evidenced by 50% false visual recognition rate of victims by families in the Bali bombing. To summarize the topic, research on forensic facial reconstruction, that is FFR techniques, incorporate new information on estimating the facial appearance in manual and computerized application. The aim of FFR is to recreate the facial appearance of a deceased and unidentified individual so that it is sufficient in resemblance to facilitate recognition. Post-mortem facial depiction is most frequently employed by forensic artists who utilize artistic ability, their knowledge of hard and soft tissue facial anatomy, and an understanding of the processes of body decomposition and taphonomic effects. Post-mortem depiction is utilized for deaths that are natural, suicidal, or homicidal.